I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll consider transformations of quadratic relations. The topics which we'll be looking into are given here on the first screen. The beauty of this video is that we are going to have 12 multiple choice questions after we'll understand all the concepts. And that will help you to review what we have learned so far about quadratic relations. When we talk about transformations, we have to always begin with the base function or the parent function. So whenever we talk about transformations, we'll discuss with respect to y equals to x squared. Now y equals to x squared is your base function, or you may also call this as a parent function. Amongst the graph shown here, we do have the graph of y equals to x squared also, which is shown here in red. So this particular graph shown in red is y equals to x squared. Let me highlight the points which are also referred to as the key points. So one of those key points is 0, 0, 1, 1. So at 1 the value is 1, 1, 1. At 2, the square of 2 is 4. So at 2 we have 4, which is the next point for us. 2, 4. Now as you can see, every graph will have a line of symmetry. For y equals to x squared, the line of symmetry is x equals to 0. Right? So x equals to 0 is axis. That is to say that there are points on both sides which could be reflected, and you could get those points, right? So from 0, 0, it lies on the axis itself, which is right there. So this line is x equals to 0, the axis which we are talking about. It really means that there is a point which is reflected, and you get a point as minus 1, 1. And the other point also, which we'll normally consider, is minus 2, 4. Clearly, the output is positive. The y value is always greater than or equal to 0. Square of a number is always positive. So that is all about the parent function which we should know about before getting into the transformations. So I hope this part is very clear. What parent function we are talking about? It is y equals to x squared, where y is always greater than or equal to 0. And these are the 5 key points which we should consider. The axis x equals to 0 is extremely important, and this graph goes through the origin, symmetric about the line y equals to x equals to 0. Now we'll consider one by one all the transformations. We'll begin with vertical transformation. So here in this particular table, what you notice is the base function or the parent function y equals to x squared and the 5 critical points which we had just talked about. Again, the red graph here represents the parent function y equals to x squared, and throughout this video I'm going to use this particular graph to show you how the points actually change as we transform them. So transformation means that the graph will be changed in some way or the other. Now when we say vertical transformations, what do we mean? Vertical translations, it is, to be very specific. Let me highlight the word vertical translations. That means the graph of the function will be moving vertically up or down. So it moves vertically up or it moves vertically down. In either case, the only change which happens is in the y value. So the y value will change. Shape remains same. Is that clear to you, right? Shape is same. So that is kind of basic to understand, right? So if I, in general, have a point on the graph as xy and the transformation takes place, which could be written as y equals to x squared plus k. In that case, the x values will remain same, however, the y values will change by k. Well, if k is negative, this will be minus, right? Does it make sense to you? Now, keeping that in view, we have two examples here. In one example, we are saying that green color for x squared plus 2, where k is positive 2. The graph is shown right there, which is this graph, and you can obtain the graph by moving 2 units up. So the point which was at 0 has now moved 2 units up. The point which was at 1 has moved 2 units up to 3, and the point which was at 2 has moved to 4. You can observe this in the values. So the x values are exactly same. You can see that the x values are minus 2, minus 1, 0, 1, and 2, but the y values are increased by 2. And that happens because of this 2 plus 2. So y values increase by 2. So 4 changes to 6. Is that clear to you? 1 to 3, 0 to 2, 1 to 3, 4 to 6, 4 plus 2. However, if you're looking at the function which is x squared minus 1 means what? Change is negative 1. So basically, in this particular case for minus 1, we are bringing the graph down by 1 unit. So when you bring it down by 1 unit, the y values will be 1 less than the original y value. Perfect. In general, we can write as we wrote here. If we are adding k, then the x values remain same, how the y value increases by k. If k is negative, as you have seen in the second curve, it was minus 1, it goes down. So that is what vertical translation is. So as you can see here, the graph translates up or down by k units. Up when k is greater than 0 and down when k is less than 0 or negative. Clear? And that is going to be the shape of the graph. Now let's talk about the horizontal transformation. Horizontal transformation is slightly difficult to visualize, but if you look at the graph first, I think it becomes clear. So basically we do have the same parent function y equals to x squared sketched here, right? The red one. And you see the two graphs, one moving left, one moving right. So the green graph here is moving right by 2 units, and this is because of this. So x minus 2. If I place x equals to 2, it becomes 0, right? So the y value becomes 0, and you get right there. Is that clear to you? Right. So the translation now happens because of the equation y equals to x minus h whole square. So in this case, the points which were x and y now change to x plus h and y remains same. It is a horizontal translation. You get my idea. So the graph actually moves 2 units right if we have x minus 2. That means h is positive. So in this case, h is greater than 0. And it moves 2 units, rather in this case, plus 1. The graph moves 1 unit to the left. Perfect. In this case, h is less than 0. It is negative 1, right? So in this case, h is negative 1. And so it moves left. So that is how you have to visualize. Here are the key points which we have mentioned. So we have taken just 3 points this time, but you could add to this list, right? So I'd like you to add to this list the other two key points, which are 1, 1 and 2, 4. The y values remain same. So when you're going to write down the points, then let me just show you how you have to write it. 1 and 1, the x value changes. Minus 2 means you have to add 2. So x value becomes 3 and the y value remains same. In this case, when it is x plus 1, it is minus 1. So 1 minus 1 is 0, and well, 1 minus 1 is 0, and the y value remains as 1, right? So these values are not really correct. I would like you to look into these values and change them, right? So these values are actually not correct. Let's redo this. Okay, so in this particular case, if I have x minus 2 whole square, in that case, the point which is minus 2, 4, the x value will now become 2 more. It becomes 0, the y value remains same. Do you get the idea? But if I have a point 0, 0, the x value you have to add 2, the y value remains same. If I have a point 2, 4, in that case you add 2 to x value, it becomes 4 and the y value remains same. Is that clear to you? So that is how you're going to get the new points. However, if you have the situation which is x plus 1 whole square, in this particular case, the x values will be moving left. That means 1 less, but the y values will remain same. So minus 2 becomes minus 3, y value remains same. 0 becomes minus 1, y value remains same. And 2 becomes 1, the y value remains same. And those points will be right there on this particular graph to sketch. Does make sense to you, right? So at minus 1, you get a 0 as shown here. So that is horizontal translations. Now let's move on and check reflections. So when you reflect on the x-axis, it comes upside down. So the red graph here again is the base function of the parent function shown right in the very beginning. The other graph, which is the green one, is reflection. So it is reflected on the x-axis, so we get the image as you can very clearly see. In that particular case, the transformation is that the xy points get transformed, and what we get here is for the same x value, the y becomes minus y. And that happens in the case of minus x squared. In the other case, which is minus x squared minus 1, what do you expect? Well, the minus 1 will further add minus 1 value to the y. X value again will remain same in this case. So for this particular transformation, the xy coordinates on the parent function x squared will now change to x value remains same, there is no change in x value. The y values become negative of y and then minus 1. So negative y minus 1 will be the new point. Is that clear to you? The last one here is minus of x minus 2. Now we have x minus 2 within the bracket. That means this time there is a horizontal shift of 2 units right. So the x value will add by 2. So the xy value will not change and the x values will become x plus 2. The y values will become negative. And that is how you're going to get this graph, and this is the graph for you. Is that clear to you? So each and every point will be transformed, and you can then plot the graph, which will look like this. I would like you to pause this video, check the results, draw it yourself, and then visualize. Now, we'll see some combinations with vertical transformation. So when we say vertical transformation, we actually mean two things. One is vertical stretch, and the other is translation. We had seen vertical translation earlier, but this time we are going to do the combination. As the name suggests, vertical stretch means that if I am multiplying by a number which is greater than 1, then it gets stretched, means narrower. So the graph here, which is the normal graph for us, is the y equals to x squared graph. So the graph here is y equals to x squared. However, the green graph which you see, if you notice, at 1, the value here is 1. However, in the graph green, it is 2. That means this is 2 times x squared. If you see the orange graph, in that case, it has been compressed going down to half, and this is half of x squared. And that is what we term as a vertical stretch. So we can say that the graph is vertically stretched by a factor of a, right? So the graph is vertically stretched. We also use the word compressed by a factor of a. Now, for convenience, whenever we have a smaller value, we say compressed. But you could say stretched by a factor of half. But technically, you should use the word compressed if a is less than 1. Is that clear to you? So if a is less than 1, we say compressed. But if a is greater than 1, we say stretched. Let this be the rule. Perfect. Now with a, it could be negative also. It could be less than 0. In that case, it is negative. And then it is a reflection on the x-axis. As we had seen earlier also. So here is an example of reflection on the x-axis, right? Now, the question here actually is, as you must have noticed by now, is to write the equation from the graph. We already have a graph and we need to write the equation of the graph. We did write the equation of the graph for the first two cases by noticing the value at the 1 itself. Now at 1, the original graph had a value of 1. 1 square is 1. However, the one in green had 2 times, and therefore we get the value of 2x squared. And the one in orange had half the value, so it is half x squared. It has been vertically compressed. So by selecting right points, we started with the origin. That means no translations. And then we check this point, and these 3 points, which are critical for the 3 curves, gave us the answer. Now let's look into the next graph. In the next graph, we have to provide equations for the orange and the green graph. Y equals to x squared is given to us as the red one, so we'll keep that as a standard. Now see what has happened. There are two things. Let's consider the green graph first. It has moved, translated 1 unit down. Since it has moved 1 unit down, we know that there is a translation of 1 unit down, right? So the k value is minus 1. So in this case, k equals to minus 1. Since vertically it has moved 1 unit down. Now, looking from this particular point, if I move 1 unit to the right, how much further down do I go? So I go 2 units down. That means that the a value is minus 2, since you are going downwards. Minus for negative. And that gives us the equation as y equals to minus 2 x squared minus 1. Perfect. So that becomes our solution for the particular graph. I hope you are getting the idea. Now let's look into the second graph, which is shown right on the top. Now in that particular case, what you notice is that the graph has actually moved 1 unit up. That means the k value is plus 1. Now, if I move 1 unit to the right, how much up do I go? I go only half the value. And therefore, the graph equation is half x squared plus 1. Perfect. So that is how, if you look at it, very easily you are going to get the answers. So straight from the graph, you can actually get the answer just as I got it. Now, first look into the translation. Your graph is not going through the origin. Vertex is not at the origin. That means there is a translation. Graph has moved vertically up and down. That means the translation is vertical. The k value changes. And next step is to check whether it has been stretched or compressed and find that factor by checking the value at 1. Is that clear to you? So that is critical. So you get both the equations right. Let's look into more complicated cases as we move along. This time, we have a very general purpose graph, and what we need to do is again write the equation from the graph. I will like you to now pause the video, focus on the question, and write down the equation. We'll again begin with the green graph first. What do you notice? Our vertex has moved right. That means there is a horizontal translation. So the term is x minus 1 whole squared. Perfect. This is because of this. It has not moved up or down, so that means k is equal to 0. Now let's look into the y value. Whether when I move one step, how much further down or up it is. So from 1, the one step here is 2. Now at this point, I go down and hit it here, which is also at 2. Do you see that? So a value is minus 2 since we are going down. So we have minus 2, and so the equation is y equals to minus 2x minus 1 whole square. Does it make sense to you? That is how you're going to get this equation. Perfect. Now, let's look into the other graph, the orange one. This time, the vertex has moved to minus 1. So therefore, we have x plus 1 whole square as the horizontal translation, 1 unit left. Now, if I move 1 unit, I'm just going up by half. So the value here is half, and the equation is y equals to half x plus 1 whole square. Great. So it's not very difficult provided you focus and try to follow a method just as we are trying to do here with so many examples. Now let's look into two more graphs. I would actually like you to pause the video and answer this question. So first thing, we are looking at the vertex. Let me go with this graph going down. The vertex position is 1, 1. So in this case, we can write y equals to a, we don't know, but we know h and k value. H is, we have moved 1 unit right, so it is minus 1 whole square. K, we have moved 1 plus 1. Is that clear to you? How do you find a? To find the value of a, we'll move 1 unit to the right and see how much down we have gone. We've gone 2 units down, so the a value is equal to 2. And therefore, the equation should be y equals to 2, but a negative sign since you're going downwards, x minus 1 whole square plus 1. Correct? Now let's look into the other graph which is given to us. Right there, the vertex is here. It is at minus 1, 1, and therefore the equation should be x plus 1 whole square. And it has moved 1 unit up, k value is 1. And if I go towards this step, again it is step of half, and so we get y equals to half x plus 1 whole square plus 1, right? So we get equation y equals to half x plus 1 whole square plus 1. So we are taking similar graphs so many times. The whole purpose here is to understand the concept. So I hope you are getting the concept. Move by 1 unit and check the difference. Move by 1 unit, check the difference. correct? First, get the value of h and k with the vertex. So, let me write down a note here that h and k are points of vertex. Correct? So, they are coordinate points for vertex. Now, here is the last example before the quiz. So, this time we've taken just two graphs. You need to find the equation in the terms of a times x minus h whole square plus k. How are you going to do it? Step number one, check the vertex. So we know here that the vertex here is, let me write v, in this case minus 1, 1. Perfect. That is first thing. So that means h equals to minus 1 and k equals to 1. Perfect. Now the second step here is go one step and check the value of y. It is 2. So that is the value of a. So we get a equals to 2. And now you write down your equation, which is y equals to 2 x. So you get, you're moving left, right? So x plus 1 whole square. And you're moving down. So minus 1. Correct? So k, since you move down, so it is minus 1. Sorry, minus 1. Yeah. So this point here is minus 1, minus 1. That gives you these points, and we get our equation. That's our answer. Isn't that simple? Let's do it once again for the last graph before the test or the quiz. The vertex here is from 0 you go to minus 1 and you go up to 2. So that is your vertex, right? So you get the value of h and the value of k right there. And now you have to look into the step. So if you move this step 1, it is only half, but going down, so a equals to minus half. And therefore, you could write this equation as y equals to minus half x plus 1 whole square plus 1 plus 2, right? 2 is your k value. Perfect. So that is how you're going to get the equation. So with these many examples, I hope you got all the concepts. We'll have very different type of questions which have been seen in previous test papers to follow. So here is a multiple choice test question for you. There are 12 of them coming. I'd like you to take up your paper and pen. Calculator is not required. Answer the questions and then check with my solution. Question number 1 is probably the most difficult. Which graph has the point with the greatest possible y value? So we have got four choices. Which graph has the greatest possible y value? You have to figure from the given values. So if I say minus 7x squared, the graph will be kind of like this, right? This is minus 7x squared. If I say minus something plus 1, that plus 1 really means that, and this is the vertex, right? So we have a vertex at 3 and plus 1 somewhere here. So the graph has a vertex here and it's going down from here. So that is plus 1. Now if I say in this particular graph plus 3, and that means what? That means this particular graph will be moving down from this position whose vertex here is 6, 3. So that becomes the point which is the highest. Is that clear to you? So check vertex and direction. So in this case, the vertex is 6 and 3 and the direction is down. So the maximum is there. So that gives you maximum. And that is your answer. Question number 2. The parabola y equals to x squared plus 5 is what kind of transformation? So it is definitely a vertical transformation, correct? 5 units up. So it is a translation up by 5 units. A is correct answer. So first you have to think about the answer and then look at the choices. That is my guidance. Question number 3. Which equation is the correct for the graph? So what will you look into? First point is the vertex. So vertex is at, from here, this is 2, right? So this is 2. The y value is -4. So that is your vertex. Second thing which you have to see is that from 2, if I move 1 unit right or left, how much up do I go? So from 4, I am going to the point which is 3, -3, right? So we are going up by 1 unit. So A is equal to 1. And now we can write down our equation. So first write down your equation. Y equals to A is 1, X, this is 2, right? So -2 whole square, and that is -4. So that should be your answer. So x -2 whole square -4 is option A. So again, write down your equation, then check the options. Question number 4. The parabola y equals to x -3 whole square is, this is inside, correct? So whenever we have inside, then only transformation is horizontal. And it is 3 units right. Since if we put 3 here for x positive 3, it becomes 0. So 3 units right is what we're looking into, option D, translated right by 3 units. Question number 5. The graph of the parent function y equals to x square is translated 2 units left, right? So we have moved 2 units left and 3 units down, right? So 2 units left and 3 units down. So -2, the vertex, 3 units down, that becomes your vertex. Is that clear to you? Equation of transformation function is which one? So we're looking for the vertex as -2, -3. So that is what we're looking for. So this value should be +2, and then we have to have 3 units down, so -3. So there is a typing error here. Both are same. This should have been minus. Okay. So I'm just making one of them as minus, and then we'll look into it once again. So it is translated 2 units left. So we got y equals to x plus 2 whole square and 3 units down. So -3. So now which is the right answer? X plus 2 whole square -3. I made that change here. It is option D. Question number 6. The point 3, 4 will be on the graph of which function? Well, one of the way is, here basically we are saying, when I say 0.34, I am saying x equals to 3 will give you y equals to 4. So what you could do here is substitute 3 and check your answer, right? So if I substitute 3 here, I get what? I get 3 minus 1 whole square, which is 2 square, which is 4. So that seems to be the right answer. Correct? Next option. Which of the following point will lie on the graph of y equals to 3 minus x minus 1 whole square? Now again, many points are given to you. So you have to write down the x value. So check your answer. So if I substitute -1 here, if I write -1, then what do I get? I get 3 minus -1 minus 1 whole square, which is 2 square, right? Which is 4. So 3 minus 4 is -1. So this is not the right answer. Similarly, if I write 2 here, in that case, what do I get? In that case, I get 3 minus 2 minus 1 is 1. And we get +2. That is also not the right answer. Now, if I use 3, 3 minus 2 is 2. So 2 square is 4. So I get 3 minus 4, which is -1. That seems to be the right answer. So we'll mark this up and then move forward. So we'll substitute x value and check for y. Is that clear to you? That will be the strategy. Question number 8. A parabola y equals to ax square plus b passes through the point -1, 3 and 2, 1. Find the value of a and b. Well, this is a slightly difficult question. We will involve multiple equations. I'd like you to pause the video and then answer the question. Okay. So we are given that y equals to ax squared plus b. Now it goes through a point which is minus 1 and 3. So if I substitute minus 1 for x, I should get y as 3. So I can write this as 3 times a times minus 1 square plus b, or 3 equals to a plus b. So I get one equation which is 3 equals to a plus b. Now we have the second point which is 2 and 1. So if I substitute 2, I should get 1 here. So I get 1 equals to 2 square is 4. So let me write 4a plus b, and that gives me the second equation. Now, to solve for it, we could actually take away. So I'll do this solution right here. So we have one equation which is 3 equals to a plus b. The other one here is 1 equals to 4a plus b. So what we could do here is we could take away one equation from the other. So if you do that, what do you get? 3 minus 1 is 2. A minus 4a is minus 3a. That cancels. And so we get the value of a as equal to 2 over minus 3. So we get the value of a as 2 over 3 minus, which you could write as minus 2 over 3. Now, substituting this value, we can always find the value of b. So we know from here that b is equal to, you could use any one of these equations. The first one is simpler. B is 3 minus a. So we get 3 minus 2 over 3, which is equal to 3 plus 2 over 3, or 9 plus 2 over 3, which is 11 over 3. So for us, the answer is a equals to minus 2 over 3 and b equals to 11 over 3. Correct? So that is the correct answer. So unfortunately, in the options given, none of them is correct. So we have none of them. So our correct answer is right here. And somehow, I think this value was wrongly written. So we didn't get any of those options. So, but I hope you understood the method, right? So understand method. So let me once again explain. We have two unknowns, right? A and B. And we have 2 points. That means we could get two equations. And from two equations, you can get those values, exact values, which we got. And that is our answer. Clear? Let's move on and take the next question, which is question number 9. Graph of the parent function y equals to x squared is vertically stretched by a factor of 2. Reflected on the x-axis and translated 3 units right. Equation of the transfer function will be which one of these? So you have to now figure out the reflection, incorporate reflection, vertical stretch, and translation. Get your answer, right? So I'll just wait for a minute for you. Here is how I'm going to do. Vertically stretched by a factor of 2, that means a equals to 2. Reflected on the axis means a is less than 0, so negative 2. Translated 3 units right, that means h equals to 3. And therefore, the function is y equals to minus 2 x minus 3 whole square. So minus 2 x minus 3 whole square is option B, which is the right answer. Perfect. Let's see the next question. 3 more to go. Question number 10. The graph will have only one x-intercept if which of these conditions is true? Well, the equation here is again y equals to ax plus k, right? If so, that is the equation. And the condition should be, which condition should be true for having only one x-intercept? Let's try to understand this. So the idea here is one x-intercept means that the vertex is on the x-axis. It could be either one of these. Is that correct? So we have this vertex on the x-axis. When is that possible? It is only possible when k is 0, right? So that is possible when k equals to 0. Is that clear to you? So when k is 0 and you multiply, what you get here is that a times k is 0, not a equals to 0. If a is 0, it is just a constant function. It is no more a parabola. So that becomes your solution. Clear? So these three are actually similar questions. Question number 11 is, a parabola will not have x-intercept if which one is true? But they are very, very important. One of them is always there in any test paper. Now, the condition for us is will not have any x-intercept. That means that the graph could be either always upwards or downwards without crossing the line of the x-axis. This will happen if a is greater than 0 and k is also greater than 0. That will happen if a is less than 0 and k is also less than 0. Both are positive. So here we have both positive and here we have both negative. Means their product is positive. So that is the right option. Is that clear to you? Last question here. I'd like you to pause and answer this particular question. Parabola will have two x-intercepts. So instead of one, we are now making two x-intercepts. So the situation is, let me again draw something like this. Either it is going like this or it is going like this. Perfect. So what do you notice? Well, in this graph, a is less than 0, but k is greater than 0 because it has moved up. In this case, a is greater than 0 since it is opening up, but k is less than 0 since that values come down. In this case, when you multiply a positive and a negative value, so it is positive times negative or it is negative times positive, either way, we get a negative number, so their product should be less than 0. So those are some very important questions which you have to keep in mind when you're working on transformation of quadratic functions. So we did take few questions from previous chapters just to review the concepts. And now we come to an end. I hope you have understood all the concepts. Feel free to write your questions, post your suggestions. Thanks for your time and all the best.